Our topic for this presentation is estimation of permeability from core and well logs. Group members participated in this project are Şeyra Maramazada, Ekrem Nebiye, David Keynes, and I am Gürcan Gürses. I will give a brief introduction and then talk about permeability estimation from well logs. Permeability is one of the hardest and critical petrophysical parameters to obtain. It defines well and reservoir performance. Permeability is essential for determining depth and spacing of perforation, optimal drainage point, production rate, EOR patterns, optimal placement of wells. Core, well log, and well test analysis are main permeability estimation approaches used in petroleum field. Core analysis measures data using a few cubic inches of rock. Well logs investigate a sample size in the order of a few cubic feet of rock. Well test analysis provides permeability information from a sample size of thousands of cubic feet of rock. Difficulties with estimating permeability. Laboratory analysis of cores gives more reliable data for permeability. However, it is very expensive and core data is only available for specific wells and intervals. Permeability estimation from empirical models are low in accuracy. Regression analysis provides more accuracy than empirical models. However, functional relationships are needed to be known in advance. NMR logs gives better estimation of permeability. However, NMR logs are not available for all wells. Well testing is not viable for small companies due to its high cost.
My name is David Cañas, and I will be talking about the fundamental of core analysis, including coring techniques and core sample investigation. We will be discussing some of the different techniques used to acquire the core sample and the different methods used to measure permeability of the core. Whirlline coring involves using a core head and an outer barrel system run down the well attached to a standard drill string. The inner assembly is then run in the locked into place in the outer barrel. On completion of coring, the core is retrieved by the inner barrel of the whirlline system. The disadvantage of whirlline coring is the requirement of an additional conventional trip in the case of the core head needing to be replaced. The second coring method is by explosive sidewall plug sampling, which includes firing a high-strength steel tube that cuts into the formation wall and retrieves a core sample. It is retrieved by a wire inside the tool used to convey the explosive charges. The disadvantage of this method is that it can damage formation sample. After obtaining the core sample, permeability can be measured. The first method to measure permeability is by using a gas parameter apparatus such as the RUSCA. With the RUSCA, we are able to measure and obtain gas viscosity, flow rate, and upstream pressure. The core sample length and diameter are measured separately. Using all of these values, the Darcy equation, gas permeability is calculated. There are some problems in using this method, such as Klingerberg effect, which states that air permeability will be greater than liquid permeability. It is possible to obtain a correlation between air permeability and liquid permeability that helps out fix this issue. The reason of using gas as the fluid is to avoid any chemical reactions with the core. Liquid parameter apparatus work with similar principles except it uses a liquid instead of a gas, and the flow rate is obtained differently. The apparatus allows a fixed known volume of liquid to pass across the core sample, and the time it takes is recorded. Using this method, we don't need to worry about Klingerberg effect. There are common obstacles of core data analysis as a whole, such as the number of core samples required to create a decent permeability profile that represents the reservoir. Another downside is the requirement of halting production for the core sample to be acquired. The advantage of core sample analysis is that it can be used to measure other properties of the reservoir, such as porosity.
4 methods are used for permeability estimation from well logs. These methods are empirical correlation from well log parameters, regression analysis, virtual measurements, nuclear magnetic resonance logging. Empirical correlation from well log parameters. Estimation methods are based on mineralogy and grain size, surface area and water saturation, 4 dimension. Based on available data from well logs and core data, one of those methods are used to estimate permeability. These models are based on correlation between permeability, porosity, and irreducible water saturation. However, the issue with these relationships is that they don't directly include pore throat size, and pore throats have more influence over permeability than other pore attributes. Table 4 shows that regression approach gives permeability values closer to the core than other approaches.
My name is Shahryar Maharramzada. I will be talking about estimating permeability from NMR logs. The ability to estimate formation permeability is one of the earliest benefits of nuclear magnetic resonance, which NMR logging, and remains the most important application. NMR log is the type of the well logs that does not provide direct and continuous measurement of permeability. Rather, a formation permeability estimate or index is calculated from spectral porosity measurement using permeability models that are based on combination of empirical and theoretical relationships. We will talk overview of permeability estimation technique by use of NMR logging later. NMR logs provide information about quantities of fluid present, properties of these fluids, the size of the pores containing this fluid. From this information, it is possible to estimate the porosity and permeability of rock pore space, rock composition, type and quantity of fluid hydrocarbons, hydrocarbon productivity. In sandstone reservoir, NMR has worked very well in the estimation of porosity, irreducible water saturation, producible fluid, and permeability. But the success rate is low in carbonate reservoirs with respect to permeability. In many carbonate reservoirs, porosity has been underestimated. With this underestimation in porosity, the permeability estimation becomes problematic since permeability is derived from NMR porosity. The NMR estimate of permeability is based on theoretical and core-based models shows that permeability increases with increasing porosity and pore size. Several permeability models have been developed for NMR logs. Two of them are in common use. First one is Timur-Coase models. Second one is Schlumberger-Doll-Research model. The Timur-Coase model is very flexible and has been calibrated using core data for successful use. The formula is shown. Schlumberger-Doll-Research model formula is shown below. This model works very well in water-saturated zone. The Coase and Schlumberger-Doll-Research models are not applicable to estimation of permeability in fractured formation. NMR has a long history to measure porosity that is independent of mineralogy. It can also provide information on irreducible water saturation. Depending on the tool and the mode of operation, the type of the fluid in the formation can be indicated, whether it's gas, oil, or water. Permeability and pore size distribution can also be derived. All these are in real time and on the app. If this potential were fulfilled, there would be a reduced need for coring to identify rocks and for permeability measurement from core clock.
My name is Akram Nabiev. In conclusion, we discussed few methods to estimate permeability. All methods have advantages and disadvantages in different aspects. For core analysis, the gas permeameter apparatus is easy and feasible tool to measure permeability and allow core to be reused for further research. But liquid permeameter apparatus does a better job at simulating reservoir conditions and calculating the permeability. The most reliable data of local permeability are taken from laboratory analysis of core. NMR logging has worked remarkably well measuring permeability in sandstone reservoirs, but in carbonates reservoirs it becomes problematic since permeability is derived from the NMR porosity. The application of NMR logging technology takes on even more significant in horizontal wells, where core is frequently unavailable to take. Low permeability formations, the measurements of permeability from core samples and prediction from log correlations are a difficult task. Estimation of permeability by using well logs is the cheapest way to obtain permeability. Permeability from well testing is expensive due to performing the test and loss of the production during the tests. Low accuracy of permeability prediction from the correlations in low permeability reservoirs. Functional relationships are needed to be known in advance for regression methods. Thanks for your time and for looking our presentations.